Thanks to the rapid development of technology, astronomers are making more interesting and wonderful discoveries. For example, the title of the largest object in the universe changes from one discovery to another almost every year. Some of the discoveries are so large that they surprise you with their existence. In this issue, we will discuss a very unusual and incredibly large object called the Giant Gamma Ring, which is like a teleporter for the space fleet. The ring consists of 9 gamma-ray bursts spanning 5 billion light-years. What is it? How did it come about? We will try to answer these questions. Amazingly, the giant ring consists of 9 such gamma-ray bursts spanning 5 billion light-years. It's highly unlikely that this was any kind of accident, but we can't rule it out. The gamma-ray bursts that make up the newly discovered ring have been observed from space and from ground-based observatories. They are at a similar distance from us, about 7 billion light-years. 36 degrees across the sky, or more than 70 times the diameter of the full moon. This means that 20,000 gamma-ray bursts from a ring more than 5 billion light-years across are just one random occurrence in this distribution. Most current models show that the structure of space is uniform on large scales. Other recent results, and this new discovery, challenge the principle of establishing a theoretical limit of 1.2 billion light-years for the largest structures. If the ring is a true spatial structure, it should be almost visible to the eye. Gamma rays are rotated around the center of the object due to small changes in distance. This ring can be thought of as a spherical projection of these gamma-ray bursts, which occurred a long time ago, 250 million years ago. A short time compared to the age of the universe. So how can such a structure come about? Researchers consider 2 explanations for what the observed objects look like. In the simplest case, galaxies can lie in the same plane, thus forming a single ring. This means that it is oriented almost perpendicular to the direction of the observer's view of the Earth. Another explanation is that this structural plane is not a real object, but a projection of the sphere onto the celestial plane. Dots placed randomly on the sphere will cluster around the edge of the projection circle, creating the illusion of a ring. The existence of a cluster of this size may contradict cosmological principles about the uniformity of the universe. Previous studies with the Planck and WMAP instruments limited the size of the space object to 1.2 billion light-years. It is precisely this order of magnitude that would seriously undermine the notion of unity based on microwave observations. If the author's findings are confirmed, astronomers may have to reconsider the constraints on the evolution of the universe. The first example of such giant formations was the discovery of a quasar cluster in 1982. It was about 350 million light-years across. Later, however, larger but unstructured objects were discovered. Sloan's Great Wall, 1.37 billion light-years. Hercules' northern corona is more than 10 billion years old, about 10% of the observable universe. These flat formations consist of alternating cavities and clusters of galaxies. Who knows what we'll discover tomorrow? Yes, the universe never ceases to amaze. In 1950, the Dutch astrophysicist Jan Oort proposed that all comets form a cloud that orbits the inner part of the solar system. It is not uncommon to observe celestial objects around the Sun, where material around the hottest star evaporates and is carried away by cosmic winds. These paired celestial bodies are comets. Evidence that comets leave very distant parts of the solar system is their long orbits. Astronomers record the movement of about a dozen comets every year, but in reality, all these things appear in a distant cloud. The outer part of the solar system is believed to be surrounded by them. To find the answers, we suggest going on an amazing journey. Solar system. The Sun's gravitational pull is limited relative to its neighboring stars, that is, between the Sun and the closest stars. Therefore, if the distance to the nearest stars is light-years, the solar system is on the order of several light-years. So the solar system is a very large unit, 1,000 times larger than the orbits of the most distant planets. And we have to wait tens of thousands of years for the traveling system to fly beyond the boundaries of the solar system. It would also be correct to say that the boundaries of the solar system are defined by the Oort cloud. To date, the estimated mass of the cloud is only 80 Earth masses of ejected material. Yes, it may not look like much, but the Oort cloud is actually a giant sphere of scattered material with an astonishing diameter. Some astronomers estimate that this region begins about 2,000 astronomical units from our star and ends at about 70,000 astronomical units. The Oort cloud is believed to be the grave of the planet. This reservoir of trillions of icy objects formed early in the formation of the solar system, when giant planets ejected smaller objects from its boundaries. From time to time, some of it turns towards the Sun and takes the form of a comet. The Oort cloud is hypothesized to include two distinct regions: a spherical outer Oort cloud and a disc-shaped inner Oort cloud. The stuff in the cloud is mostly made up of water, ammonia, and methane ice. It probably formed near the Sun and was dispersed into space by the gravitational effects of the giant planets early in the development of the solar system. Although there are no direct observations of the Oort cloud, astronomers believe it is the source of long-period and Galilean-type comets, as well as many Centaurs and Jupiter family comets. The outer part of the Oort cloud is the approximate boundary of the solar system, and can easily be affected by the gravitational pull of both passing stars and galaxies. These forces sometimes cause comets to drift toward the center of the solar system. Short-period comets, based on their orbits, can originate from the Oort cloud as well as from the diffuse disk. We mentioned that the value cloud contains a lot of material. But what does it represent? The outer Oort cloud is thought to contain several trillion cometary nuclei, more than 1.5 miles. The average distance between comets is several tens of millions of kilometers. Incidentally, Comet Gallia is a suitable prototype for all comets in the outer Oort cloud. The combined mass of all the large comets in the cloud is about 5 times that of Earth. The mass of the inner Oort cloud is currently unknown. Comet bodies can be trapped in the Oort cloud for a long time, ejected from the solar system, or escape into the Sun's orbit to become true comets. Comets aside, most Oort cloud objects are made up of various ices that contain substances such as water, methane, ethane, carbon dioxide, and cyanogen. However, the discovery of object 1996 PW, an asteroid with an orbit typical of long-period comets, suggests that the Oort cloud may contain rocky objects. Here is an example. Analysis of the ratio of carbon and nitrogen isotopes in the Oort cloud and Jupiter family comets shows only small differences, regardless of their individual regions. It is concluded that the objects of these regions were formed from the original protosolar cloud. This conclusion is also supported by studies of particle sizes in Oort cloud comets. It's also amazing how the gravitational effects of neighboring stars and galactic waves can change the orbit of money, making them more rounded. This explains the nearly spherical shape of the outer Oort cloud. This means that the Hills cloud, which is more tightly bound to the Sun, must eventually have a spherical shape. Recent studies have shown that the formation of the Oort cloud undoubtedly corresponds to the hypothesis that it formed as part of a star cluster of 200 to 400 stars. These larger, nearby stars likely played a role in the formation of the cloud, because the close paths of the stars within the cluster were much more frequent than today, and caused more frequent perturbations. The current position of many comets seen near the Sun is thought to be due to the gravitational disturbance of the Oort cloud, caused by tidal forces caused by the Milky Way galaxy. The tides rise and fall as the tidal forces of the Moon bend and distort the Earth's oceans. In the inner solar system, these effects are negligible compared to the Sun's gravity. However, in the outer solar system, the Sun's gravitational pull is weaker, and the gradient of the Milky Way plays a much more important role. Because of this gradient, galactic waves can disrupt the Oort spherical cloud, stretching the cloud toward the galactic center and compressing it along the other two axes. These weak galactic perturbations may be sufficient to move valuable cloud objects from their orbits toward the Sun. By the way, there are interesting calculations according to which, during the existence of a planetary system, extraterrestrial stars pass 10 times as far from the inner comet rim, making comets 1,000 times more frequent. Such an event has been going on for about 400,000 years. Up to 200 comets fall to Earth during this period, an average of one every 2,000 years. On the scale of a human lifetime, of course, this is not particularly noticeable, but on a geological scale, we can talk about a shower of money. They even tried to link such showers with extinction on our planet. In addition, information about the periodicity was explained by the presence of Nemesis, a dark star with a mass of a few hundredths of the Sun. Nemesis, according to this hypothesis, travels in a long orbit around the Sun and enters the money cloud every 26 million years. However, the Pioneer 10 station, outside the planetary system, did not experience any additional acceleration, which could be explained by the impact of Nemesis, or at least a large planet the size of Jupiter. The influence of 3 to 5 mass bodies cannot be ruled out, so the Oort cloud is a really interesting and mysterious region where there are tens of billions of money nuclei. Some of them we have already seen, others we have yet to see. We know that the minimum temperature is minus 273.15 degrees. Why? Because at that temperature, the movement of particles stops, and the heat energy they emit becomes zero. I wonder if there is a minimum temperature. Maybe there should be a maximum temperature. And logic dictates that the particle must reach a maximum at such a point that it cannot release any more heat energy. But is it really so? To understand, it is necessary to define what temperature is in general, and also trying to find the sources of the highest temperature in the universe. Let's try it out. All life, from bacteria to Krogan to reapers, can sense heat and cold directly through their senses. But given our lack of superpowers, our options are very limited. This is because this definition of temperature requires measuring temperature with instruments rather than by hand. Such instruments are called thermometers and measure the so-called empirical temperature. The empirical temperature scale defines the scale of measurement and the number of divisions between them. Here are the scales we use today, including Celsius, Fahrenheit, and more. But absolute temperature, measured in Kelvin, is entered with a single point, the point on which the measuring scale is based. Given that there is a minimum limiting value of temperature in nature, an absolute number, the upper value of the temperature is limited by the Planck temperature. This is a type of maximum temperature. The highest temperature was thought to be 10 trillion degrees. It is artificially obtained from the Earth. This absolute temperature record was obtained during an experiment at the Large Hadron Collider, the world's most powerful elementary particle gas pedal. At speeds close to the speed of light, particles collided with high-energy lead ions. When the heavy ions collided, many big explosions, dense regions of fire with such high temperatures, began to appear. At such temperatures in energy, the nuclei literally melt and form a pile of their quarks. The result was the highest temperature plasma in the laboratory. Although 10 trillion degrees is an incredibly high temperature, it seems far from the limit. As everything is limited within this experiment, technology does not allow us to go further. So I suggest going on a space trip in search of the hottest source in the universe. And we start with the closest planet, Venus. 90 characterized by an unusually dense atmosphere with a pressure equivalent to Earth's atmosphere. Due to the amazing greenhouse effect, the surface temperature of the planet reaches 480 degrees, which is more than Mercury. Many known objects can also approach the Sun at record distances. This includes the asteroid Phaedo, whose temperature can reach 750 degrees Celsius. But the object passes through the moon Io at a temperature that has been one of the biggest surprises in the probe of the Peter system by space probes. Its surface is the youngest in the solar system and has no impact craters. Measurements from the Galileo space station show that the temperature of volcanoes on this satellite reaches at least 1,340 degrees Celsius. The surface of the Sun has a temperature of about 5,500 degrees Celsius. However, about 10,000 kilometers from the surface of the Sun, there is the solar corona, which we see as a type of halo. Its temperature reaches 1,000,000 degrees, but not only that. A solar flare can have temperatures of tens of millions of degrees. However, the Sun is an ordinary star in the universe. Surface temperatures of ordinary stars range from 2,000 degrees Celsius in red dwarfs to 30,000 degrees Celsius in blue dwarfs. But it should be remembered that there is a special class of stars. Stars known as Wolf stars can have surface temperatures in excess of 50,000 degrees Celsius. The number of known stars of this type in the local group of galaxies may be only a few thousand. Such stars are characterized by high-density, planetary crust-like debris shells. They are thought to represent the final stage of single large-scale stellar evolution before the supernova explosion phase. Their hottest star is believed to be WR102, with a temperature of 210,000 degrees Celsius, 500,000 times that of the Sun. This star has a mass of 20 solar masses and a radius of less than 0.4 solar radii. But stellar debris is even higher. For example, the discovery of the hottest white dwarf RxG0439 with a temperature of 240,000 Celsius was announced in 2015. We are approaching the exotic remnants of the stars. These are neutron stars that have even higher surface temperatures. Their maximum radiation is in the X-ray range and gamma rays. Thus, the brightest sources of gamma rays are the neutron stars in the Crab Nebula, the Sales Nebula, and the quiet radio star Geminga. When a neutron star is born, its surface temperature is estimated to be about 100 billion degrees Celsius. This is a high temperature but far from extreme. Finally, we reach black holes. In front of us, for example, is a black hole with a stellar mass of X1, the brightest X-ray source in the sky. Recent observations have shown that the effective temperature of the nearest quasar core is 30,273.40 trillion degrees. The effective temperature of dark matter in active galactic nuclei is about zeta Kelvin, tens of millions of times the observed temperature of matter seen in these objects. The universe is hiding even hotter things, but we can't reach them yet. And yet, we understand that the highest temperature was during the Big Bang, or when inflation began. The theory says that the temperature of our universe was equal to the Planck temperature. Modern physics believes that this point is the highest, and that it is not 10 trillion degrees, but much higher. In the new theory, the limiting temperature should be 142 centillion. Yes, as you can see, this figure is much higher than our Earth experiment. But why is there such a difference? The thing is, there is such a thing as a state, and there is such a thing as a particle's velocity distribution. The concept of temperature for the former system state is not defined at all. The temperature is strictly defined for one species, a state of equilibrium called Maxwell's velocity distribution. This probability distribution, found in physics and chemistry, is at the heart of the kinetic theory of gases, which explains many fundamental properties of gases that are not accounted for experimentally, including pressure and diffusion. From this, we can conclude that there seems to be no theoretical absolute maximum temperature, as the system can be heated to any desired temperature. Another question is what processes will occur at high temperatures and whether we can describe them. This is because at extreme temperatures, molecules begin to dissociate into atoms first. Then atoms begin to decay into nuclei and electrons, then nuclei into nuclei, and then nucleons into a quark-gluon plasma, the fundamental particles that make up quarks, protons, and neutrons. But what comes next is unclear. Quarks are elementary particles that have nothing to decay into. What happens at high temperatures, pressures, and superspeeds? It is not clear at all. So the maximum limit should work in this case. We don't know what will happen at extreme temperatures. So the question obviously remains open. No light is visible. Invisibility is one of his most recognizable traits. We only see it when it hits our retina. Yes, we cannot see light that just passes through without reflecting anything. Imagine an empty, dust-free, completely sterile room. Before the end of the experiment, the light must not have time to reach the walls, or the walls of the room must be black to completely absorb the light. Now imagine the lantern there from the outside. That's great! You cannot see the lantern, not the lantern itself, but the light it gives off. Paradoxically, light is invisible. We can't see it up close unless it's reflected off of something. If there was something reflecting the light, even dust or water droplets, to scatter the light, we would be able to see it. But since there is nothing in the beam, and we are looking at it from the outside, his light does not reach us. If there was a second light source in the room, we could see the flashlight, but not the light it emitted. Rays of light, no matter how powerful we can get them even with a laser, pass each other as if there was nothing in their way. These considerations are included in the book The Structure of Reality by British physicist and philosopher David Deutsch, one of the founders of the concept of quantum computing. The book as a whole makes it clear that the age of grand philosophical systems is not a thing of the past. The author provides a coherent answer to one of the most fundamental philosophical questions. What is the essence of reality? Today we try and figure it out. As you move toward the observer in the reflector and back from the flashlight, the reflector will appear even smaller and even worse when only a point is visible. The question arises, is light really able to propagate infinitely in the finest rays? The answer is no. At a distance of about 10,000 kilometers from the lantern, its light would be too faint for the human eye to perceive, and an observer would see nothing. Therefore, man would see nothing but a more sensitive seeing animal. Take the frog, for example. His eyes are several times more sensitive than human eyes. This is enough to make a noticeable difference in the experiment. If the watcher were a physical frog, and he moved away from the flashlight, there would never be a moment when he lost it completely. Instead, the frog would see the flashlight begin to glow. The flashes occur at uneven intervals and will increase as the frog moves away from the flashlight. But the individual lights would not be brighter. Already 100 million kilometers from the flashlight, the frog would see only one flash per day on average. But this flash would be no less than any other flash observed at a different distance. Unfortunately, we do not know the language of frogs, which means that there will be no scientific debates with them. That is why researchers use photomultiplier tubes in real experiments. These are more sensitive light detectors than frog eyes, and reduces light through dark filters. Observing light 100 million miles from the source is somewhat problematic. However, neither the principle nor the result changes. Imperceptible darkness, uniform darkness, glare, and even brightness, no matter how dark we use the filter. This flash proves that there is a limit to the uniform distribution of light. Each flash is caused by a photon hitting the retina. Light rays are weakened not because the photons themselves are weakened, but because they are separated from each other, and the space between them increases so the light hits the retina. This property of light only occurs in discrete quantities and is called quantization, and a single piece of light, a photon, is called a quantum. Quantum theory, by the way, gets its name from this property that is attributed to all measurable physical quantities. Yes, everything that surrounds us and seems to be continuous is not. There are many different phenomena in quantum physics. Quantization is the simplest. Let's get back to our photons. You've heard many times about Thomas Young's 2.5 experiment. This experiment belongs to the general class of dual-path experiments, in which the original wave is split into two separate waves, which are then combined into one. Changing the path length of the two waves results in a phase shift, creating an interference pattern. Young's experience is the fallacy of theories that treat light only as a stream of particles. If the photons exhibited only corpuscular properties, the screen would show two brightly lit areas behind the light and a dark area between them. Young's experience forced physicists to consider the wave properties of light, meaning that each real photon must be at least 1 trillion shades of green. But interference is not limited to photons. Quantum theory is perturbed by any particle. Therefore, every real neutron must be accompanied by shadow neutrons, each electron, shadow electron mass, etc. This means that reality is much larger than it appears, and most of it is invisible, and the objects and events that we can observe with instruments are only the tip of the iceberg.